My name is Edel Chipkemboi Kiprop, and I will be demonstrating how I built my 8-bit ALU using the hierarchical approach, starting with the basic logic blocks and combining them to 1-bit ALU slice, then tiling to create an 8-bit ALU. So this is my 8-bit ALU, but to build this I had to come up to combine my circuits using my logic decoder circuit, full adder, and then I made a 1-bit ALU slice, and then used this 1-bit ALU slice to tile them together, forming an 8-bit ALU. So for my logic circuit, which is this, I have A, B as my inputs, and enable in or enable in, not B enable in as my enabled inputs. I have A and B out, and out or out, not B out as my outputs. I'll demonstrate the functionality of my circuit. If I switch on A and B, A out and B out are switched on. If I turn on my AND enable in, the AND out is switched on. If I have either A or B switched, either one of these switched on, the AND out is switched off. If I have both of it switched off and my AND is on, it's still, AND out is still switched off. But if I have both of them switched on, the AND out is switched on. If we have the OR enable in switched on and both inputs A and B are switched on, the OR out is switched on. If we have either of the two switched on, the OR out is still switched on. If we switched off both A and B, the OR out is switched off. For not B, if we have not B enable input switched on, the not B out is switched on. But if we switch on B, the not B out is switched off. And this is my logic circuit. For my decoder, I have two inputs, that is F0 input, F1 input, and I have 4 outputs, that is AND, OR, not B, and add enabled out. So when we have both F0 and F1 switched off, the AND enabled out is switched on. If we have F0 switched on and F1 switched off, the not B enabled out is switched on. If we have F0 as off and F1 as on, the OR enabled out is switched on. If we have both F0 and F1 switched on, the add enabled out is switched on. For my full adder, I had A, B inputs, add enabled in input, and carry in input. If we turn on A, B, add enabled in and carry in on, this output, that is C out and sum out, are switched on. If we switch off the carry in, the sum out is switched off. If we switch off the add enabled in, both C out and sum out are switched off. If we switch off A, if we switch off A and B is still on with add and carry in switched on, the C out is switched on and the sum out is switched off. If we have B switched off and A switched on, the C out is on and the sum out is off. And this is my full adder. For my 1-bit ALU, I have the logic unit, the decoder, and the full adder. I have the invert A in, enable A in, B in, enable B in, and each with their own outputs, the enable in inverter and enable A out. There is an F0 out, the F1 out for F0 in and F1 in. The decoder, the logic unit, the carry in going to the full adder, and carry out and arith out. When we have all our inputs switched on with the carry in and the enable in inputs, the C out is switched on, but the arithmetic out is switched off. If we have the carry in switched off, the arithmetic out is switched on and the C out is switched off. If we turn it on, C out is on, arith out is off. If we switch off our inverter and have our carry in on, both outputs are switched on, but if we switch off our carry in, the arith out is switched off. If we switch off our enable inputs, the outputs are switched off, and this is my 1-bit ALU slice which I used and tiled them together to form my 8-bit ALU, in which I will demonstrate its functionality using 4 test cases, that is test 8, test 6, test 4 and test 1. For test 1, we have A inputs as 100, so 1000, 100, and we have enabled A and B switched on, and for B we have 1100, 0011. So our expected output is 10001000. So our circuit has passed test 1. For test 4, we have A inputs as 0011, 1100, 1100, and then for B we have 0, 1 1 1, 0, 0 1 1 1, and we have the enabled inputs on, F0 as off and F1 as on, and our expected value is 0 1 1 1 1 1 1 1. And test number 4, our circuit has passed. For test number 6, the inputs were 0 0 1 1, 1 1 0 0, and then 0 1 1 1 0 1 1 1, and then F enables B and on, and then we switch off the F1 to be off and F0 to be on. So the expected value is 100, so it is on 0 0 0, on 0 0 0. So our circuit has passed test number 6. For test number 8, the inputs for A are 0 0 0 1, 0 0 0 1, and then for B it's 0 1 1 0, 1 0 0 1, and then for F1 and F0 we turn them on, and the expected value is 0, so it's off, on 0 1 1 1 1 0 1 0, and our circuit has passed test number 8. And that was my demonstration for my 8-bit ALU